Well, this is really about notation and saying a few things which are fairly obvious, but they're worth saying anyway. Right then, we say that A is a supertype of B, where A and B are reference types. So there could be arrays, they could be interfaces or classes. If we can say, if we can set some variable of type A equal to some variable of type B, if we can do that, then we can say that A is a supertype of B. And you indicate this by writing A colon greater than B. And that's the standard notation. That's one used in the Java language spec anyway. And just a note, A and B could be the same type. They don't have to be different, because A is a supertype of A automatically. Right. So what governs it, of course, is whether you can set a variable of one type to a variable of the other. That's the key thing for judging whether something is a supertype. There's a similar meaning for subtype. It just means the opposite way around, really. A is less than colon B means that A is a subtype of B. And again, you allow the possibility of A equaling B. So if A is a supertype of B, then B is a subtype of A. It's nothing significant, really. Right, how do we find all these supertypes of some type A? Well, the answer is what you do is you follow all the extends clauses in the definition of A, and if it's a class, you follow all the implements clauses as well, and then you've got everything. Except there's one extra thing to remember. Any class that doesn't extend anything, of course, it implicitly extends objects, so don't forget that. And one extra thing, any interface that doesn't extend anything is regarded as a subtype of object. Okay, so you might wonder why that is, but if you think about it, it's fairly obvious. If you've got a reference of type object, it can always be set equal to a reference of type interface, or some interface type. And if you think about it, that's what you'd expect, because supposing the reference to the interface contains something. Well, if it contains something, it would have to be some sort of class which implements that interface. In which case, if it's a class, well, the object will take it without any problems. Or supposing it's not set to equal to anything, you haven't set it, then there are two possibilities. It's either a field. If it's a field in a class somewhere, if this interface type is a field in a class somewhere, this a variable of interface type, that is, it's going to be set to null by default, in which case null is quite acceptable to object. If the variable of interface type we're talking about is a local variable to a method, then if it's not been set to anything, it's going to be random. But if you try then and access it and use it to set some variable of type object to it, then the compiler will give you an error, because it will trap it and say, you haven't set this variable yet, you can't use it. And so it won't get past the compilation. So all the bases are covered if you think about it. That's why you can do this. That's why you can set you can say that any interface, it doesn't extend anything else, is a subtype of object. So it's all covered. Oh yeah, and note this. You'll see I'm using this proper notation here. In the previous one, I had to use this because this is all high resolution now, but the lower resolution screen size, this thing didn't show up well at all. And it was even worse when I was talking about direct subtypes, because then they had a little subscript on them. That's the official notation anyway, and that got lost completely. So I had to adopt something else. I had to invent something, but I've gone back to the standard one now. So here's an example of what I keep refer to all the time. This is a tree of types and subtypes, supertypes and whatever. So if you can say that M is a subtype of K, or K is a supertype of M, I put a line in like that. And if you look at this, this kind of makes sense. You can't draw these things in arbitrarily, by the way. of course, you'll notice these I've got put classes in yellow here and interfaces in green, and you'll notice a class can only extend one other class, right? So you can't have a line from a class to two different classes, because that wouldn't work. You also can't have a line from an interface to a class, because interfaces don't extend classes. An interface can extend many other interfaces, as you can see, and if it doesn't extend anything, like this example here, it has to extend object. So those are just sort of constraints on how the diagram can be drawn. But I think I've managed to get them all correct. It wasn't at one time, but I had to change this. But I think that's okay. That diagram looks okay to me. It doesn't look as if it's impossible to do in Java. So you just have to make sure that you don't put things in extending others that are not permitted. And this, of course, this has got to be this has got to be an interface, I think. It can't be a class, for example, because it can't be a class because you've got these interfaces extending it, and they have to be interfaces because one of these two, F or R, has got to be an interface, because Q can't extend two different classes. So I've chosen R to be an interface, so that means that's got to be an interface, and so on. So there are sort of constraints like that built in.